All right, as I said at the end of the last video, the derivative is one of the big ideas of calculus, and it's just the instantaneous rate of change of a function. So if we have a function f, then the instantaneous rate of change at a point is the derivative at that point. So the notation that we use is this f prime, right? So if our function is f, then f prime is the notation we use to indicate the derivative, which is again the instantaneous rate of change of the function at that point. And we can think of it as either the slope of the graph at that point or the slope of a tangent line, where the tangent line is a line that just touches the curve at that point. So let's take a look at the components of the derivative here in this next example. All right, so now example 4, we're just given a graph of a function y equals f of x and asked to determine whether each of these quantities are either positive or negative or 0. So all we're going to do is answer this as either positive or negative or 0. And so the first one is just f prime of 1. Okay, so what I want to do, this is x equals 1, so I'm going to find x equals 1, and I'm going to come up to the point on the graph, and it's asking for f prime at 1, and I need to know, is that positive or negative? And so what I'm going to do is look at the slope of a tangent line. So if I draw a tangent line, let me actually make it a different color. Let's make a tangent line just so you can see it a little better. It's hard to draw a line, a straight line, but so you get the idea there. That is an approximation for a tangent line at that point. And so I want to know is the slope of that line positive or negative or 0. So you can see that as x increases, we're going downhill, right? The y value is decreasing. So that means that the slope is negative, which means f prime is negative. Okay? So again, it's just the slope of that tangent line. Now, what is this next thing? It's f of 2 minus f of 1 over 2 minus 1. So what is that? That is the average rate of change between x equals 1 and x equals 2. So is that positive or negative or 0? Well, let's draw what that looks like. That's a slope, right? It's a change in y, right? Because if y is equal to f of x, right? So it's a change in y over the change in x. I'm going to erase this line so it doesn't get in the way. And so let's draw what that line would look like. Okay, so here is about where f of 2 is, and this is f of 1. And now we're going to draw a secant line. Now it's hard to, it's just a line connecting those 2 points. It looks like it overlaps with the curve, although it doesn't necessarily. But it's the average rate of change, and is that positive or negative or 0? So again, it's going downhill. That line has a negative slope, so this is negative. Okay. All right, so now the next one is asking, okay, f of 5 minus f of 4. All right, so let's look at on this graph where f of 5, here's 5, so we're going to come up to the graph. I'm trying to go straight up. All right, that's f of that point, the y value at that point would be f of 5. And the y value of this would be f of 4. And so now this is not a rate of change. This is just the change in the y value, right? So you can see that the value of f of 5 is bigger than the value of f of 4. So if we subtract, if we subtract them, we're going to get a positive value. So this one is positive. Okay, right? Because it's just a difference between the y values. It's just the rise. It's a rise. There we go. It's the rise from the function value at 4 to 5. All right, next question is the instantaneous rate of change of f at x equals 4. Okay, now this is the same as f prime of 4, right? It's the slope of the graph at that point. It's the instantaneous rate of change, which is the derivative. So if we draw a tangent line at 4. So let me change back to red here. Let's draw a tangent line. You can see that that tangent line has a positive slope, right? So this value is going to be positive. All right. F prime at 3. All right, so let's look at it at 3. F prime of 3 seems to be right here at the bottom of this curve, right? So it seems like it's it's the minimum value of the function at anywhere near that point. So if I draw a tangent line there, like if it was something less than 3, it looks like it would have a negative slope. Anything greater than 3, it looks like it would have a positive slope. But at 3, I'm going to erase this line again so that we have a little more room to write. And okay, so if I draw a tangent line here, it looks like it's flat, right? It's changing direction. It looks like the f prime, the derivative, the slope of the function at anything less than 3, if it's just a little bit less than 3 would be negative. Anything a little bit greater than 3 is going to be positive. So I'm going to say that this slope is horizontal. It's a horizontal line, so it has 0 slope, right? It has no rise, and it's all run. So rise over 1 would be 0. All right, 0. All right, and the last question here is just asking, where is the derivative of the function equal to 0? Well, we just found one point, one x value where the derivative is 0, right? So we know when x equals 3, it looks like the derivative is 0. Now, where else is the derivative 0? Well, if you follow along this curve, you can see that if I look at, tangent lines over here, they seem to be positive. Tangent lines over here seem to be negative. And where it changes direction is right about here. So the tangent line here, which appears to be about x equals -1, right? So x equals -1 appears to be a point where the slope changes direction from positive to negative, so it has to pass through 0. And so that would be another point where the derivative is 0. All right, I'll meet you in the next video.